Good afternoon everyone, my name is Anutku Ilgan. I'm a third year computer engineering student from METU, and today I'm going to talk about the ProBinDeePred, a web service for the protein drug binding affinity prediction based on the deep learning study. My supervisors are the Volkan Atalay and Ahmet Rifaioğlu. As moving to presentation overview, I will first start talking about the drug and target interaction background, then I will move on to details of my study. So the drug and target protein interactions are the recognition of the interactions between chemical compounds and the target proteins. These chemical compounds are binding to target proteins in order to produce therapeutic effects, such as lowering our fever, and they work like a key-unlock mechanism, as shown in the figure 1. Specific compounds binding to the specific proteins with higher efficiency than the others. This depends on many factors, such as the structural, chemical, and the biological features of the proteins. However, there is no exact formula for this, and the computational methods are introduced at this point. Because the traditional ways to find drugs are slow and expensive, and the vast amount of the chemical space consisting of the 19,000 approved drugs and 5,000 proteins just for human body is also preventing the exhaustive researches for this purpose. So the computation methods are in need. The state-of-art solutions for this purpose are the docking simulations and machine learning methods. Docking simulations provides more performance in this test, but they require 3D crystallized structures, which are mostly unavailable for proteins. So the machine learning methods are in trend, but they're hard to implement. They require high computer proficiency and multidisciplinary experience. Therefore, our solution for this is that creating pre-trained models for individual target protein families used in drug discovery researches with a deep learning study, and making a web service that connects biological databases and these pre-trained models to serve users an easy access to bioactivity data, whether predicted or measured. Moving on to details, first I constructed a web service as shown in the figure 2. It consists of the local database to store the already predicted values, the pre-trained prediction models for the protein families, and the protein feature matrices, and also it communicates with the Crossbar API, which consists of a database of the biological information, returning the bioactivities and the other information required for calculations. And moving to the routine of the web service, users are providing the chemical and compound IDs or string representations of them and the protein families, along with their emails, and after checking of the validation, all possible compound and target protein pairs are listed, and for these pairs, all existing bioactivities from the Crossbar API is get, and after that, if there are any remaining pairs, a prediction is made for them through the pre-trained models, and all of the results are totaled in a CSV file and sent to the user as an email attachment. Moving to the methods of the training the models, I use the ProBinDeePred, which is a hybrid multi-channel deep learning study for DTI prediction purposes. It provides more reliable and improved performance compared to state-of-art deep learning methods for this purpose. Moving to the details of the ProBinDeePred, that it uses the proteochrometric approach, which means it uses the both protein and compound features for the training. Protein features are extracted using their sequences taken from the AA index. Their physiochemical, sequential, and structural properties are extracted as shown in the figure as the 5 separate matrices, and the chemical features are extracted from the string representations as the ECFP4 extended connectivity fingerprints. And these feature matrices are then fed into this neural network architecture you can see in the figure. The proteins are fed into a convolutional neural network, consists of 2 convolutional plus pooling layers, and also the compounds are fed into a feed-forward neural network, and the inception layer of the proteins and the last layer of the compounds are concatenated and fed into 2 full connected layers, and the output is a single neuron showing the predicted bioactivity value of the given pair. More of this neural network's details can be found in the original paper. Moving to the datasets used in this study, is the ProBinDeePred is already tested with the original study with several datasets such as Davis and PDB bind. For this study, I used the gold standard protein families stated by the Yamaneshi and colleagues, which are the GPCR, nuclear receptor, and the kinase protein families, and they are taken from the these information are taken from the UniProt and the Campbell databases, and the randomly sampled 12,000 bioactivity values are used for each preliminary training. Moving on to details of the results, As in the figure 5, you can see the scatter plots, and in the table 1, you can see the dataset average performance tests for the MDPred taken from the original paper. As you can see, MDPred is overall showing better performance than the other state-of-art solutions. Moving to test that I did, you can in figure 6 and table 2, you can see the scatter plots and the average evaluation values of the training data sets I used. These results are showing correlations with the original MDPred study paper, and also they are showing promising scores for the in terms of the training. Therefore, as conclusion, today I talked about the study that in the study, a web service with a purpose of predicting DTI is constructed. Given the protein and compound pairs, users are serviced with the bioactivity values, whether predicted or measured from the databases. For further improvements, improved and extensive models of the target protein families can be implemented in the system. I believe this study will enable researchers without high computer proficiency to make predictions for drug discovery researches easily. And here are my references used in this presentation. Thank you for your time, and I can answer your questions if you have any.